Hi, welcome for developing, sorry again. Hi, welcome for guidelines for developing UI components. My name is Chava, and I'm a full stack software engineer and tech lead at Google. Today, I'm going to share common guidelines for designing the component hierarchy of a web application. In the past 2 years, I've been implementing and maintaining a complex UI model, and the guidelines and best practices I'm going to share today are the lessons that I've learned from my own personal experience. I'm also going to talk today about Ninja Warrior. This is my favorite TV show these days. I'm sure you all know it, but anyway, each episode has a series of obstacles, and the candidates that complete the obstacles at the best time move to the next level of the competition. I've been implementing an application that stores the candidate results in each and every episode, and we will analyze the component hierarchy of this application throughout this talk. So let's start with the background. What are UI components? So UI components are the building blocks of a web application. The buttons, the inputs, the drop-downs are the basic components. They are usually part of a design system which is shared across the organization. You can see here in the slides the basic components of Angular material. This is the application I told you about that stores the results of candidates in each and every episode. So you can see at the top the drop-down where it is possible to choose a candidate, and then at the bottom there is the list of obstacles, and then it's possible to set the start time and end time and the completion status of each obstacle. And you can see highlighted the basic components that are being used in this application. Custom components are a composition of basic components, and you can see here highlighted one custom component of this application. This custom component is responsible for the results of a candidate in a single obstacle. Custom components can also be composition of multiple other custom components, as highlighted here. React and Angular are component-based UI framework, which means in practice that everything is a component. However, it is up to the developer to decide what is the hierarchy of components in the application, and this is what we are going to talk about today. So let's start with the guidelines. These are the guidelines that I will going to elaborate on today. Some of them are clean code guidelines and best practices that should be applied to UI code as well, while others are dedicated to UI development. The code examples I will share today are implemented in Angular. However, they are relevant to any component-based UI framework. So the first one is single responsibility principle. It is a very basic and well-known clean code guideline, and when you apply it to UI code, it means that every component should do one single task. The advantages of single responsibility is by the fact that components that perform a single task are smaller and therefore easier to maintain, and also if a functionality is implemented in multiple components that each one of them has a single well-defined task versus one large component, it is much easier to reuse some aspects of a functionality. Those are indications when the single responsibility principle is not kept. When your components have too many inputs, and also when your tests are very long and, like, as a developer, you feel that they're hard to maintain and execute. Next, Composition. The idea behind composition is to combine multiple smaller components together to achieve functionality. The code is split into multiple composable components, and then there is a parent component that is responsible for orchestrating all the components and passing information between them. The advantages of composition is that it is easier to test functionality if you test each and every aspect of it separately. And also it is easier to replace some parts of your functionality if they're encapsulated in their own independent component with inputs and outputs. Reusability. Aim to reduce repeated code. You should introduce shared component for functionality that is repeated across the application, and this way the functionality is tested once and have the same look and feel everywhere that it is used. Single level of abstraction. The Clean Code guideline says that all statements of a method should belong to the same level of abstraction. And if you take this into UI development, your component should be composed with other components at the same level of abstraction. So for example, if your component contains both custom components and basic component, it might be a code smell or an indication that another layer of abstraction should be introduced. So I've been talking about 4 guidelines, and let's take a look about how they can improve the code. And as I said earlier, I will use the Ninja Warrior application in this demo. So you can see here the template. In case the entire code of the Ninja Warrior application is implemented in a single component. It is hard to maintain in real life, it's not readable in real life, and also in this slide, it's very hard to read and understand the code. Highlighted here, the template for the functionality that displays and later get inputs from the collaborator from the user, about results of a single candidate in a single obstacle. So we can apply the single responsibility principle and introduce a separate component for this functionality, and in this component test all the aspects and all the test cases that are possible for a single candidate in a single obstacle. This is how the component will look like, and also you can see how it is being used. Next, this is how the page code looks right now. It is much better and much more readable. However, we can improve it even more. You can see here a custom component together with basic component, which is an indication that we can introduce another layer of abstraction. Yes, you can see here highlighted the basic components being used. And I would suggest to take this code that is actually responsible for choosing a candidate and encapsulating it in its own dedicated component that will test all the aspects of candidate selector and displaying the list of candidates in the dropdown and so on. You can also see here the template of the parent component, and this parent component will basically implement composition, because this parent component will be responsible for taking the candidate selection and propagating this information into the obstacle result components. I would also say that by the fact that we implemented a single layer of abstraction, the composition here give us another advantage, that if we want to replace the candidate selection and use a different presentation for it, it's completely okay, and it will affect only the implementation of this candidate selector. Reusability. When I show the component that is responsible for a result of a single candidate in a single obstacle, you saw two duration pickers for the start time and end time, and we can introduce a shared component for them that will be responsible for an input that is in the form of minutes and seconds, that will be responsible for displaying this kind of input and also validating that it is in the right format. Okay, so one last guideline is presentation versus container. This is a life cycle of an average web page. First, there is the load data step. Then the data is being presented. The third step is getting user inputs, and eventually the page is responsible for storing the updated data in the server. Let's drill down into loading the data. It involves the identifier from the router, then dispatching API requests. In some cases, additional cascading API requests should be dispatched, and anyway, the loading code should handle failures in any of the API requests. And if I drill down into the last step, which is saving the data, then it is needed to dispatch API request to save or store the data in the server. Sometimes there is logic to decide whether it will be create API or update API dispatched, and of course, handle failures. So as I just demonstrated, in some cases, the logic to load the information and store the information can be complex. In those cases, I would recommend to split the code into a presentation component and container component. The container component, which is also referred to as a smart component, is responsible for getting data and storing data into the, storing data. So it's basically responsible for using the router and the state management. And the presentation component, which is also referred to as a dump component, is responsible only for presenting the data, getting the user inputs, and emitting an event to the container component about data updates. So basically, the container component is responsible for step 1 and 4, loading the data and storing the data, and the presentation component is responsible for step 2 and step 3, presenting the data and getting user inputs. This would be the template of the container component. We don't see here the code that is responsible for loading the data, but we do see how all the data that is needed to present the list of candidates and the list of obstacles is passed into the presentation component as inputs. As I said earlier, this best practice is relevant when the logic to load the data and store the data is complex. I would say that it is not always relevant, this guideline. It is relevant when the logic is complex, and also when the same presentation is reused with multiple data sources. For example, graph components or table components will usually be a presentation-only components in order to allow multiple containers to use them. Okay, so to summarize, those are the 5 guidelines which I find very useful when designing a component hierarchy of an application: the single responsibility principle, composition, reusability, single level of abstraction, and presentation versus container. I would also say that applying guidelines is an iterative process. When you introduce a new functionality, a new module, it is usually based on all those best practices. But as time goes by, you're adding small features here and there, and in many cases, the component becomes too large and hard to maintain and not applying the guidelines. So it is important to notice that, accept it, and also invest time in refactoring the component when it is becoming hard to maintain and too big. Thank you very much for listening. If you have any question, you are welcome to contact me on LinkedIn. And also, if you have additional best practices for designing a web hierarchy of a web application, I would be very happy to discuss them. So contact me also for that on LinkedIn. Thank you very much.